I was asked to do a quick explanation on how to balance this particular reaction that we had in our notes using base. We can tell from the amount of hydroxides that we have present that this is definitely going to be a reaction done in base. So how are we going to go about that? Well, we're going to start by balancing it in acid. So regardless of whether we want to balance an acid or base, we're going to have to figure out where the reduction and the oxidation are. We do that by assigning our oxidation numbers. So zinc by itself is an element uncombined and is defined as having an oxidation number of 0. In the nitrate ion, each oxygen is -2, 3 of them is -6. Nitrogen would have to have an oxidation number of +5 to maintain that -1 charge on the ion. In the ammonia ion, hydrogen, we know, unless it's attached to a non-metal, attached to a metal, I should say, always has an oxidation number of +1. So 3 of them is +3, nitrogen gets -3. Ammonia is one of these cases that we just habitually write backwards. Usually we put the positives first. This one is just done this way because this one's always been done. Okay, now when we assign the oxidation numbers in zinc hydroxide, this particular crazy big ion with a -2 charge, I'm going to do the numbers inside the brackets first. Hydrogen gets a +1 oxidation number and oxygen gets -2. That means each hydroxide grouping has a -1 charge, of which there are 4. So I've got -4 from the hydroxides. In order to maintain this -2 charge, zinc has to have an oxidation number of +2. All right, so where is our oxidation on our reduction? Well, I can see already that zinc has gone from 0 here on the reactant side of the equation, and it's gone up to +2. So there's my oxidation because zinc's oxidation number's gone up. And nitrogen's gone from an oxidation of number of +5 before the reaction down to -3 after the reaction. So we're going to go ahead and make our big redox chart. And I'm going to put the words reduction and oxidation, redox. And let's start separating these out. Well, we said the oxidation was zinc. So we have, before we react, elemental zinc in its metallic form, and after the reaction, we have this crazy zinc hydroxide, ZnOH4, with a -2 charge. From the reduction, we can see that was the nitrogen. So the nitrogen started off as the nitrate ion, the NO3-, and that turns into an H3, the nitrogens do, with no charge after the reactions. So going through the steps, we start by balancing just our redox species. So I have 1 zinc before, 1 zinc after, that's good. 1 nitrogen before, 1 nitrogen after, that's good. The next thing we balance is oxygens, and we do this by adding waters. There are 3 oxygens in nitrate and none in ammonia, so I'm going to add 3 water molecules to balance the oxygens. On the oxidation half reaction, there are 4 oxygens in zinc hydroxide and none on the zinc side, so I'm going to need to add 4 water molecules to give 4 oxygens on both sides. Next step is to balance hydrogens, and here we still use protons. We'll switch this to a base after. So taking a look at the total amount of hydrogens in the reduction side, we have 3 hydrogens coming from the ammonia, and 3 groups of 2 is 6. So I'm going to need a total of 9 hydrogens. So I'm going to put 9 protons. On the oxidation half reaction, I've got 4 times 2 is 8 hydrogens as reactants and 4 as products. So I need 4 more on the product side, so I will put 4 protons on the product side. Finally, we need to balance charge. So taking a look at where the charges are at the moment. From the nitrate ion, we have a charge of 1-, and from the protons, we have 9 pluses. So we're at +8 here. On the other side, both the ammonia and the water have oxidation numbers of 0. You always add electrons to the side that has the higher charge because electrons bring charge down. And I can clearly see that I'm going to need 8 electrons to bring this charge down so it's zero on both sides, so that my total charge before is equal to my total charge after. Taking a look at the oxidation half reaction, zinc has no charge, nor does water, so we're at zero charge on the reactant side. On the product side, we've got 2 minuses in charge on the zinc hydroxide and 4 pluses in charge from the protons, which gives me a total charge of +2. So I'm going to need to add 2 electrons to the product side in order to make sure that the charge there also balances. All right, now I'm looking at adding these two half reactions back together. I've already made sure that both halves of the reactions balance in terms of the number of redox species, the numbers of oxygens, hydrogens, and finally in terms of charge. But I know my electrons are going to have to cancel. I've got 8 on the reduction side and 2 on the oxidation side, so before I add these together, I'm going to multiply everything by 4 so that the electrons in will be equal to the electrons out. So we're going to rewrite these two equations. A reduction half reaction looks like this. I've got NO3 minus and 9 protons and 8 electrons as reactants. I have NH3 and 3 water molecules as products. From the oxidation half reaction, I'm going to write this immediately underneath. And again, I like to line my arrows up so that when I cancel, I don't make as many mistakes. Remembering to multiply by 4, I'm going to have 4 zinc atoms, and 4 times 4 is 16 water molecules. And on the product side, I'm going to have 4 groups of zinc hydroxide ions, which is a big, crazy looking ion, but that's what we have. 4 times 4 is 16 protons, and 4 times 2 is 8 electrons. Okay, now before I can go and add these up, we're going to check to see what we can cancel. First thing we always check to see if we can cancel is electrons. 8 electrons in cancels 8 electrons out. It's important that we do that step. There are more things we can cancel. I have 9 protons as reactants and 16 as products. So I can see right now that all 9 of these are going to be gone. And we're going to cancel 9 of the 16. And we'll be left with 7 protons remaining. Continuing on, we also have water molecules on both sides of the arrow. I can see that we have 3 water molecules here. That will cancel 3 of the 16 here, and we will have 13 water molecules remaining. Okay, at this point, let's add everything together. We'll take a look at what we have. Okay, so I will have an NO3 minus. The protons are gone, the electrons are gone. I'm going to have 4 zincs, and I'm going to have 13 water molecules. And on the product side, I'm going to have an ammonia, NH3. These waters are gone. I'm going to have 4 of those zinc hydroxide ions. I'm going to have 7 protons. This is a great place to check before we go on. I have -1 from the nitrate. I have 0 from the zinc and 0 from the waters, so I'm at -1 so far. I've got 0 from the ammonia. I've got 4 groups of -2 is -8 from the zinc hydroxides, and 7 groups of +1 is +7 from the hydrogens. So I'm at -1 after. So far, this reaction balances, and it's important to check because there's no point in going on if we've already can find a mistake. But at this point, we're balanced in acid, and this is a reaction that needs to be balanced in base. So to do that, I go, where's my protons? And they're over here. I have 7 protons as products. So I'm going to add 7 hydroxides to these protons and turn this whole thing into 7 water molecules. There we go. We've got 7 of the water molecules. But to keep it balanced, if I have 7 hydroxides to the products, I have to add 7 hydroxide ions to the reactants. Now there's one more thing I can do. I have water on both sides. So all 7 of these water molecules are going to cancel out. We're going to have 7 of the 13 cancel out here, and I will have 6 water molecules remaining. All right, let's write this out one more time and see what our overall reaction looks like when we balance it in base. So what do we have left? Well, I've got this NO3 minus. I've got this nitrate ion. And I've got 4 zinc atoms, and I've got 7 hydroxides, and I've got 6 waters as reactants. And on the product side, I've got an ammonia, and I've got 4 of the zinc hydroxides, and that is everything that we have. So again, a quick check to make sure that we've done this right. We have 1 minus from the nitrate, 0 from the zincs, 7 minuses from the hydroxides, and 0 from the waters is a total of -8 on the reactant side of the equation. We have 0 charge from the ammonia ion, and 4 groups of -2 is -8 from here. So -8 on both sides. We know we have this reaction balanced properly.